Done a lot of work in class with algebra tiles. And the idea behind algebra tiles is basically that we have some lengths. So if I have some length that is an arbitrary length, I'll call it x, and I have another length that I'm just going to call 1. So x, I don't know how long it is. I know that 1 is 1 long. So I have these lengths. And with these lengths, I can arrange things like if this is x long and this is x long, I get a square. And think of the area of that, x times x is x squared. Or I could have something that's 1 long on one side and x on the other side. X times 1 is x, so this is an x tile, it's the area. And then I could also have a 1 by 1. In other words, this is 1 long, this is 1 long, its area is 1, so I'll call that my 1 tile. And if we flip them over, they become red and they become negative. We've talked about using these to add and subtract and combine. Now, I've also talked about using them to multiply. And at first, we were doing things like if I had let's say 3x plus 2's. Notice this is a multiplication, 3 times x plus 2. So I can think of that as an area. So if this is 3 long, there's my 3. And then this side is x long, and this side is 2 long. And if I actually do those multiplications, in other words, fill in that area, so notice these are measuring the side lengths. This is x long, this is 2 long. But now I have x times 1, so this is an x tile, this is an x tile, this is an x tile, so I have 3 x's. And then in here, 3 times 2, I've got 6 1's in here. So 3x plus 6, which is 1. And we've shifted that to something more generic, where we just say this side is 3 long, this side is x long, this side is 2 long, and then we can do our multiplications. 3 times x, 3 times 2 is 6. And in class, we took a long time to develop this. It wasn't this quick. Now I can do some other multiplications here. For example, if I had x plus 4 times x minus 2, say. If I was doing it with tiles, I would say, let's see, one of these sides is x plus 4, so this is x long. 1, 2, 3, 4, that's 4 long. This is x long, this side. And then this is negative 2, so I would say, okay, a negative 1 and another negative 1. So let me fill it in here, and then I'll worry about the shading because I have to deal with positive and negative values. So these would be negative. These are negative x's in here. If I have a positive times a negative, these would all be negative, all these little ones that are in here. So I've got an x squared. Here I have 4 x's. Here I have negative 2 x's, and in here I have negative 8. And so basically I have x squared plus 4x minus 2x minus 8. 4x's minus 2x's, like these two would combine with 2 of those to make a 0. So I'm really left with just 2 x's. X squared plus 2x minus 8. Again, we spent a long time in class developing this. And shifting it to the generic rectangle, where we get to a point where it's like, I don't really need to do all the little things anymore. I've got an x plus 4, I've got an x minus 2, x times x is x squared, 4x minus 2x minus 8, combine them all up, and I get that. And then we've pushed it to larger multiplications, things like 3x minus 5 times 2x plus 7, something like that. And I know that, lots of people have used different ways to do this algebraically. We're trying to push to get away from the model, but we're going to hold on to the model for a little while because it helps us undo the multiplication later. But one of these sides is 3x minus 5. Whoops. Doesn't really matter which side I put it on. One of these sides is 2x plus 7. And then I can do my multiplications. 3x's times 2x's is 6x squared. Minus 10x, right? Negative 5 times 2x. 3x times 7 is 21x. 7 times negative 5 is negative 35. And then we've got all these pieces. 6x squared, 21x minus 10x. That's negative 11. Oh, no, that's positive 11x minus 35. So that's the idea for multiplying these together. Later on, in one of the later videos, we'll talk about how to undo it. In other words, if I'm given this, how do I get to that? That would be called factoring.